So in this video, we're going to use logarithmic differentiation to differentiate a composite exponential equation. And a composite exponential equation is simply an exponential equation that has the variable both in the base and the exponent position. So the simplest possible case is x to the x. So we'll take the function f of x equals x to the x, and we want to find what does f prime of x equal. What is the derivative of x to the x? Again, composite. It's composite because the variable occurs in the base position and in the exponent position. And this is the simplest possible case of a composite exponential equation that we can write. And the idea is one that we've been using. What we're going to do is take the natural log of both sides of our equation, and we're doing this because the variable's in the exponent position, and what we want to be able to do is get the variable out of the exponent position. And the logarithm and logarithms in general are tools that we have that can do that. So using log properties now, the exponent can be brought down in front of the natural log, and the base gets left behind. So we wind up having the natural log of f of x equaling x times the natural log of x. And then what we'll do is take the derivative with respect to x, take d dx of both sides. We know from the work that we've been doing over the last several bunch of videos that the derivative of the natural log of crap, if we have the natural log of crap and we take d dx of that, we're going to get the form crap prime over crap. That's a big result that we've been using the last few homework assignments now. So the derivative of this side is just going to be f prime of x over f of x. And this is going to equal, over here, what I want to notice, I have the product of two functions. I have the function x being multiplied by the function natural log of x. And because I have a product of two functions, I'm going to use the product rule. And the product rule says take the derivative of the first function and multiply it by the second one. So the derivative of x is 1. So I'm going to get 1 times the natural log of x plus, then the product rule says take the second function and multiply its derivative by the first function. So we're going to take the first function x and multiply it by the derivative of the second function. And the derivative of the natural log of x is just 1 over x. So this is going to equal, well, I'm trying to figure out what f prime of x is. That's the question we're trying to answer. If f of x is x to the x, what is the derivative of f? And right here, I have the derivative of f sitting there. So I'm just going to multiply both sides by f of x. So I'm going to put everything on this side into parentheses and multiply by f of x. And that's going to give me 1 times the natural log equaling the natural log plus x times 1 over x equals 1, as long as x isn't equal to 0. And I know x can't be 0 because 0 to the 0 is an indeterminate form, so x equaling 0 won't be a part of the domain of this particular function. And then this is times f of x, but f of x is just the function x to the x. And so this is the derivative. And this is where I would, in general, say is the place to stop. So I would say stop here. This is good, it's nice, it's factored, but if you wanted to have fun, because everybody knows calculus is fun, if you wanted to have fun, then I actually would take and distribute this in. So I would get x to the x times the natural log of x using the distributive property, plus x to the x times 1 is just x to the x. So again, this is where I would stop. Now we're just having fun. And then look, log property says if I have some stuff being multiplied by the natural log function, I can bring it into the natural log function, and I have to put it as an exponent on the stuff that's inside. So x is on the inside, and we'll take x to the x by log properties, and we'll put that as an exponent on x. And that's fun. There you go. Logarithmic differentiation of a composite function. This is what you want to get right here.